Hi again, my name is Islamiata BC and I'm a tutor at the Natural and Social Science Lab at Miami-Dade College, Kendall campus, and today we'll continue with our gas law series. In this video, we'll go over the ideal gas law. Now before we go over the law, let's first go over what an ideal gas is. An ideal gas is modeled on the kinetic theory of gases, which has four basic postulates. First, gases consist of small particles or molecules which are continuous in random motion. The volume of molecules present are negligible compared to the total volume occupied by the gas. Intermolecular forces are negligible, therefore meaning that they have no attractive forces between molecules. And pressure is due to the gas molecules colliding with the wall of the container, in other words, meaning that it undergoes elastic collisions. Now let's go over the law. The ideal gas law is PV equals nRT, P standing for pressure, V standing for volume, N for the number of moles, R for gas constant, and T for temperature. The ideal gas law can be used to solve for any unknown variable within the law, the initial and final values of any variables within the law, as well as partial pressure. Please note that the gas constant's value is actually dependent on the units of pressure, temperature, and volume. Now that you know a little bit about the ideal gas law, let's actually do some problems so you know how to work on it. So let's practice. So let's start on our first practice problem. This problem actually states, using the ideal gas law, calculate the pressure in atmosphere of 0.652 moles of oxygen gas occupying a 10-liter cylinder at 30 degrees Celsius. As you can see on the left-hand side, I already wrote out the ideal gas law, PV equals nRT, and I also noted the values that were given to us. As you can remember, we are solving for pressure, and as was stated in the first video of the ideal gas law, certain variables need to be made sure that you have certain units. So number of moles is moles, volume is in liters, and temperature needs to be in Kelvin. So I actually showed you how to convert that here. Now our gas constant, as you can recall, is actually dependent on the units of pressure, volume, and temperature. So in this case, our value is actually 0.0821 liters times atmosphere divided by Kelvin times mole. Now, in order to get this problem started, we're actually going to isolate pressure. So we're going to do that over here. So PV equals nRT. And in order to isolate it, we're going to get rid of volume and move it to the other side. So we're going to divide by volume on both sides. Volume is going to cancel out over here, and now you have pressure by itself. And now all you can do is plug in your values. So pressure equals 0.652 moles times 0.0821 liters times atmosphere divided by Kelvin times mole. Multiplied by 303 Kelvin divided by volume, in which is 10 liters, which gives you a total of 1.62 atmospheres. And that's one way of solving an ideal gas law problem. Now the next problem is a little bit different, and you'll see how. Problem states, calculate the number of moles of a sample of neon gas at a pressure of 500 torr at 25 degrees Celsius and with a volume of 400 milliliters. As you can see again on the left-hand side, we write out the ideal gas law and the values that are given. Now, as you can see, the units for pressure here is actually torr instead of atmosphere. So because of that, remember the gas constant is dependent on the units of pressure, temperature, and volume. Our R value, our gas constant, is actually different. It is now 62.4 liters times torr divided by moles times Kelvin. So in this problem, we're actually solving for mole, so we're going to manipulate the equation. I'm going to do that over here. So we're going to write it out again, PV equals nRT. And because we're trying to isolate moles, which is N, we're going to divide Again, it's constant in temperature on both sides. This is going to cancel out, and you're left with N equals PV over RT. And now we can just plug in our values. So pressure is 500 torr. Volume is 0.4 liters. Excuse me, let me actually get rid of that. Divided by gas constant, 62.4 liters times torr, divided by moles in Kelvin, multiplied by 298 Kelvin, and which gives you approximately 0.11 moles. And that's your value for N, which is the number of moles. I hope this video helps in helping you understand the ideal gas law. In our next video, we'll actually be going over how to find molecular weight and density using the ideal gas law. Thanks for watching.